What is the approximate length of the Himalayan range? Which mountain range forms the northern boundary of the Deccan Plateau? And which is the longest peninsular river? For aspirants of competitive exams like the UPSC or SSC, the sheer volume of geographical data often leads to a reliance on rote memorization. Brute forcing facts about altitudes and rock types is an inefficient way to master a landscape this complex. The Indian subcontinent functions as an active, interconnected geological machine. Every modern feature, from the flow of its rivers to the composition of its soil, is a direct result of the tectonic forces that assembled the landmass. To understand this machine, we use the age, altitude, economy triad. The geological age of any region determines the rock types found there, which in turn dictates the elevation, the soil quality, and the industrial resources available today. We are going to build the subcontinent chronologically, starting with the oldest Archean bedrock and moving forward in time to the most recent river sediments. Tracing the assembly of the land reveals the internal logic of the subcontinent, making geography intuitive rather than a series of isolated facts. Removing political markers reveals a landscape defined by 4 distinct physical zones. The Himalayan ranges form the high-altitude northern wall. The Indo-Gangetic Plain serves as the central alluvial agricultural hub. The Deccan Plateau forms an ancient southern shield. Finally, the coastal plains act as narrow marine transition zones along the seas. These regions represent 4 interlocking layers of a single geological story, with each layer directly influencing the climate and productivity of the next. The oldest layer of India is the Deccan Plateau. Formed during the Archean era, this region is a surviving fragment of the Gondwana supercontinent. It forms a massive inverted triangle, bounded to the north by the Narmada River and flanked by the western and eastern Ghats. Because this landmass is hundreds of millions of years old, it is composed of stable crystalline rocks, primarily igneous and metamorphic types like granite and gneiss. Approximately 66 million years ago, massive fissure eruptions flooded the region with basaltic lava, creating the thick, layered formations known as the Deccan Traps. This ancient, highly pressurized bedrock is the reason the Deccan serves as India's mineral vault. The age of the plateau concentrated vast deposits of iron ore, coal, and manganese, providing the raw materials for the country's heavy industry. On its western edge, the Western Ghats form a continuous high-altitude barrier. This wall intercepts the moisture of the southwest monsoon, forcing heavy rainfall that sustains tropical evergreen forests. In contrast, the eastern Ghats are lower and highly eroded. Major rivers have cut wide gaps through the range, resulting in lower rainfall and a drier landscape. The entire plateau has a gentle westward to eastward tilt. This slope dictates the flow of the Godavari and Krishna rivers toward the Bay of Bengal. The Narmada and Tapti rivers are the exceptions. They are forced westward into the Arabian Sea by the unique structural constraints of rift valleys. The stability and extreme age of the Deccan are the primary factors behind the region's concentration of mineral wealth and industrial development. As the Indian Plate surged into Eurasia during the Cenozoic era, the crust began to buckle, creating the world's youngest fold mountains. This collision occurred in successive pulses over millions of years. Each pulse forced a new section of the crust upward, resulting in 3 distinct parallel mountain tiers. The inner Himalayas, or Himadri, represent the tallest pulse. Rising above 6,000 meters, this granite-cored massif houses the glaciers that feed the Indus, Ganga, and Brahmaputra river systems. South of the peaks lie the middle Himalayas. This range, built of complex metamorphic rocks, features steep slopes and deep valleys that house most of India's high-altitude hill stations. The final, southmost tier is the Siwaliks. These are the youngest mountains, peaking at 1,500 meters and composed of the debris shed by the taller ranges to the north. Because they are made of uncompacted rock debris and sand rather than solid crystalline cores, the Siwaliks are unstable and highly susceptible to landslides. Collectively, these ranges act as a climatic barrier. They shield the subcontinent from cold Arctic air while trapping monsoon moisture over northern India. The Himalayas function as a dynamic erosion engine, providing the constant supply of water and sediment required to sustain the rest of the country. The immense weight of the rising Himalayas created a massive depression at their base, a 4-deep trough. For millions of years, the river systems originating in the Himadri have carried billions of tons of eroded sediment down the mountains, filling this trough. This process formed the Indo-Gangetic Plain, which now contains up to 2,000 meters of deep alluvium across an area of 7.25 lakh square kilometers. Unlike the mineral-rich Deccan, this region is defined by its agricultural productivity. The recent river deposits create a highly fertile soil, ideal for large-scale wheat and rice cultivation. The resulting food security is the reason the plains are the most inhabited region in India, supporting a massive population density. This same pattern of river-led deposition continues at the edges of the peninsula, creating the coastal plains. The east coast is wide and defined by the massive deltas formed by sediment flowing off the plateau. On the west coast, the steep drop of the Ghats leaves only a narrow strip of rocky terrain and backwaters. These plains are vital for maritime trade and fishing, and they contain the offshore basins responsible for much of India's oil and natural gas production. The plains and coasts are the subcontinent's youngest features, proving that recent geological history is the primary driver of India's modern agricultural and trade systems. Organizing these zones by age reveals a predictable system. There is a direct relationship between the young, towering Himalayas and the ancient Deccan Shield. Rock types transition predictably from the south's hard granite to the loose, fertile alluvium of the plains. Applying this model allows you to deduce a region's traits simply by knowing its geological age. We can now revisit the sample exam questions using this logical framework. The Himalayan length of 2,400 kilometers, the Western Ghats peak of Anamudi, and the Deccan's inverted triangle shape. These features make intuitive sense once you understand the land's structural foundation, and the Vindhya Range is clearly identifiable as the structural separator between the northern alluvial plains and the southern crystalline plateau. Every topographical feature in India is part of a single story, one tectonic engine driving the climate, the rivers, and the national economy. Understanding the first principles of how the land was assembled reveals the internal logic behind the subcontinent's topography, climate, and development.